Okay, so today the topic which we are going to discuss is regression. So first of all, let us try to understand that what is regression. So regression basically is the relationship between two variables. Okay, so regression. So regression basically tells you the relationship between two variables. Right. So it is, the extended form of correlation. Like in correlation, correlation just used to tell us that whether the relationship between two variables is positive or negative, right? Maybe they have direct relationship or maybe they have indirect relationship. But in case of regression, we try to understand the relationship between two variable in a deeper sense, in a better sense, that if there is a change in variable 1, maybe variable x, what would be its impact on variable y? So it will tell you how much change there will be in other variable when variable 1 will change, right? But in case of correlation, it never used to tell you what would be the impact, right? It only tells you that whether there is a direct relationship or inverse relationship. But regression will tell you the direction of relationship, whether positive or negative, plus the extent, like how much impact. For example, there is let's try to see the relationship between the variable with the help of this graph. So here we have two variables x and y. On x-axis we have x variable and on y-axis we have variable y. So if there is, as you can see here, if there is a if x is 1, so y is somewhere here less than 1. When it has reached 2, x reached 2, so here it is somewhere around this value, 1 point something, 1.5 or 1.6 you can say. Then again, if it is here, like if x is 3, then y is around 2, right? Then again, if x is 4, y is here, so it is somewhere 2.5 or something. Again, if x is at 5, y would be somewhere near to 3, right? So this graph basically tells you the relationship between two variables x and y. So similarly in regression also we try to understand the relationship between x and y. If there is 1% change in x, what would be its impact on y? How much change would be there in y? So change can be either positive or negative, that is direct or inverse relationship between x and y. But it will also tell you one more thing, that what would be its impact. For example, if 1% change in y, there is 2% change in y. There is 1% change in x, there is 2% change in y. Or maybe 1% change in x, there is 1.5% change in y. So in regression, we understand what would be the extent of change in one variable if its other variable is changing. So here, the two variables which we have, we understand that in these two variables, one is independent variable, and other one is dependent variable. So we will always have two variables, independent and dependent variable. So for example, if we want to check the impact of price change on demand, right? So here price would be independent variable, and demand, because demand is affected by price. So demand would be dependent variable, right? So in regression, we always have two variables. There can be multiple dependent variables also, or maybe multiple independent variables, sorry, also. So there can be n number of, because the demand of any product would not only be affected by price. There can be other factors also, like change in technology, or maybe fashion change. So a number of things can be there, right? Cost. So so basically, in nutshell, we can say that regression is about finding the relationship between one independent and one dependent variable, right? So now, in usual equation, we always say that x is independent variable and y is dependent variable when we normally calculate regression. But in statistics, the kind of questions we are going to do here, we can calculate, there can be anything like maybe x is independent or maybe y is independent, right? So there can be different cases. So the first case is where we want to calculate y on x, right? So the first case is y on x. So y on x, it means that x here is independent variable and y is dependent variable, right? So this is the meaning. And the formula for regression is byx is n into summation of xy minus summation of x into summation of y divided by n into summation of x square minus summation of x square. And first we'll calculate byx. So by on x. So basically byx tells you that if there is, you know, 1% change in one variable, what would be the change on other variable? Okay, so here I'll just write it down so that it will be more clearer to you. So we call it least square line of regression also. Least square line of regression of y on x, right? So here the constant x, constant b, sorry, not x, the constant b is called the regression coefficient, the regression coefficient of y on x. So it measures the change in y with corresponding change in x, with corresponding change in x, right? So when we calculate y on x, it means y is dependent on x. So what would be the change in y if x is changed by 1 unit, right? So y on x is, it measures the change in y with corresponding change in x. So similarly, and beta is the constant. B we call beta also, we call it beta. So beta is the constant value, right? And when we try to calculate, x on y. So x on y, bx on y, or the constant b in regression line x on y measures the change in x with corresponding change in y. So here x is dependent variable. Here x is dependent variable and y is independent variable. And in above case, so always remember that if whatever the first value is, if byx is there, so here y is dependent and x is independent, and when we calculate bxy, so x is dependent and y is independent. Whatever the first value is, that is dependent. So here it was y which was dependent, and here x was independent. Right? So now we have to, in whatever questions we'll do, we will calculate both by on x and x on y, where once x is independent and once y is independent. Because maybe we don't know which value is independent. In certain cases, we may not know that whether in two variable which one is independent. Like the example which I gave you, it was clearly, understandable that in price and demand, price is independent and demand is dependent. But there can be situations where we don't know which variable is independent and which variable is dependent. So in that case, we calculate both by on x and x on y. We take once x independent and take y once independent, right? So the formula is mentioned here, n into xy minus sigma x into sigma y divided by n, when x is in whatever independent value is there, right? We write it in denominator. Here for example in this part where x is independent, so in denominator we wrote x is independent, so we wrote x square sigma n into sigma x square minus sigma x square square. And in next case where y is independent, so we wrote y in denominator. So whatsoever is independent variable, we'll write it in denominator. And then we'll calculate the regression equation. Now let's just straightforward move to the practical part. Let's try to understand this concept with the help of an example. So now we have, excuse me, yes. Can you please show the formula again? I think we can move forward now. Yes, ma'am. Okay. So now let's try to solve this question. Now, for example, we have two variables x and y. So we have to calculate regression lines as well as beta also. B stands for beta, right? So the first variable is x, then we have y, then 1, 2, 3, 4, 5, 6, 7. This is x. Then we have y. In y we have 2, 4, 7, 6, 5, 6, 5, 6, 5. Now we will calculate first summation of x and summation of y. Summation of x and summation of y. So summation of y is 35 and summation of x is 28. Now we have to calculate the rest of the values. Like here you see in the question, what do we need? Summation of y and x we need, summation of x square we need, summation of y square we need, and summation of xy. All these things we need, right? So here I will write xy, then x square I need, and then I need y square. So these things I would need. So let's first calculate x into y. 2 ones are 2, 2 fours are 8, 3 sevens are 27, 4 6 are 4 6 are 24. Sorry, this is 21, not 27. Then this is 24, 25, 36, 35. Now we'll calculate summation of xy. So summation of xy is 151. Now we'll calculate x square. X is 1 ones are 1, 2 twos are 4, 9, 16, 25, 36, 49. Now we'll calculate summation of x square. So summation of x square is 140. Similarly, we'll calculate summation of y square. 2 twos are 4, 16, 49, 36. Then we have 25, again 36, 25. Then we would need summation of y square. Summation of y square is 191 here. So we have got all the values now. Okay, one more thing we would need to apply in the formula of regression is mean of x and mean of y. So that we'll also calculate. Now let's just first we'll calculate by on x. And then we would need bx on y. I will just solve it simultaneously. Right. So now we'll put all the values. So n is, how many values are there? N is here 7. 7 into summation of xy is 151. minus summation of x is 28 and summation of y is 35. Then again n is 7 into summation of x square is 140. Then summation of x square. So summation of x is 28 we have. So we'll square it. Similarly, we will put values for b x1 y. So again n is 7 into summation of x y. Numerator will remain same, 151. X is 28. Y, summation of y is 35. Summation of y is 35. And then n is 7 into summation of y square is 191. Right. So this is what we have obtained. Now we will solve it further. So 7 into 151 is
1057.
1057. Okay. 1057. Then 28 into 35 is 980.
980.
980. Then again 28 into 28 we can calculate 784. 784 and 7 into 140 980. Right. Now similarly we will calculate for byx, this one. So here we are. Numerator will remain same, 1057, and 28 into 35 is 980. Then again now denominator will be different. So 7 into 191 is 1337. 1337 minus 35 into 35 is 1225. 1225. Now we will solve it. So here 1057 minus 980. 1057 minus 980 is 77. And 980 minus 784 is 196. 196. Now we'll solve this part also. Here we get numerator, we get 77 divided by 1337 minus 1225 is 112. 112. So now we'll just solve it. We'll change it in decimals. So 77 by 196 is 0.3928. 0.3928. And similarly 77 by 112 we have to calculate.
0.87.
How much? 0.87. 0.687. Okay. So now we have calculated b x on y and y on x, right? So these two things we have calculated. Now the next thing we have to calculate is regression equation, right? So regression equation of here y on x and then regression equation of x on y. X on y, right? So now we have the formula with us. So for this first we need to calculate mean also, because in formula there is mean value also. So y on x, this is the formula. Similarly x on y, this is the formula we have. Now we first calculate you know mean. To calculate mean we will apply the formulas of mean. Okay, to calculate mean, summation of x, that is 28 and n is 7, so the mean is 4. This is how we have calculated. Now summation, now for mean of y, mean of y also needed. So summation of y is 35 and n is 7. So the value we got is 5. Mean of y is 5. Now we can apply the values into the formula. Here. So here, y means x and y would remain constant. We will not change it. Okay. Because we want to calculate the equation of regression. So y minus mean of y is 5. Now byx. So beta y on x is 0.39 something we have calculated. So I'll just write 0.39. 0.39 x minus mean of x is 4 like this. And similarly we will calculate for x on y. So x will remain x only and mean of x is 4 we have. So I'll write 4 here. Dxy we have calculated 0.68. So I'll put 0.68 here. 0.68 and y minus mean of y is how much? 5. Okay. Now we'll just solve it. So this would remain y minus 5 equals to 0.39 x minus 0.39 into 4, 1.56, right? And similarly for this part also we will calculate. X minus 4 equals to 0.68 minus 0.68 into 5, 3.4. Now we will solve it. So here we get y equals to 0.39 x. So minus 1.56 plus 5. It means we'll deduct it. 5 minus 1.56. We get 3.44 plus 3.44. 3.44. And for regression line x on y, answer would be x equals to, this is 0.68 y, not only 0.68. So 0.68 y. So 3.4 minus 3.4 plus 4. So 4 we just calculate 4 minus 3.4. Answer is 0.6 plus 0.6. Okay. Plus 0.6. So this is how we have calculated both x on y and y on x. So this is a regression equation also. Plus these value which we have calculated, beta y on x and x on y, what does this indicate? So when we have calculated byx is 0.39. So probably around 3%, okay? So 39%, not 3, 39%. So if there is 1% change in x, there would be 39% change in y. This is what it indicate, right? And similarly, the other one was how much? 68%. So this is how we have calculated, right?